Welcome to qnawire.
All right, so to determine the charge, we're going to have a little bit of dimensional analysis fun. All right, so to find the charge, that is going to be equal to the dipole moment over the radius, or the bond length, I should say here, which is also the radius between them. And so we know that we've got 1.24 debye as the dipole moment. We know that the bond length is 1.60 angstroms. However, neither one of these units is really useful for us if we're trying to figure out the overall electronic charge. So what we have to do is convert angstroms into meters. And so 1 angstrom is 10 to the minus 10 meters. And we have to convert the debye into something that has coulombs in it, because coulombs is our unit of charge. And so 1 debye is 3.34 times 10 to the minus 30 coulombs times meters, charge and distance. And then we have to convert that into electronic charge. And so the charge of 1 electron is 1.60 times 10 to the minus 19 coulombs. And so just make sure we have everything cancel out except our electron here. And so our debye and our debye cancel out, angstrom and angstrom, meter and meter, coulomb and coulomb. So we're left with our electronic charge. And we've got 3 significant figures here. So the charge is 0.162. All right, so what does that mean for us here? Where is this charge going to go? Well, if we've got chlorine and oxygen, the electronegativity of chlorine is about 3.0, 3.1, somewhere in that range. Oxygen is 3.4, 3.5. Remember, the higher electronegativity is going to wind up getting the more negative partial charge. So the chlorine is going to have a charge of positive 0.162, and the oxygen would have a charge of negative 0.162. Remember, in covalent substances, we can have slight positives and slight negatives. They're just not integers. And so what is our molecule going to look like based on formal charge? Well, we've got chlorine and we've got oxygen. We have 7 and 6 electrons. So it's going to have 13 electrons total. Now that's a little weird, okay? Because normally we have substances with an even number of electrons, which is why we're going to look at the anion in a little while. But when we want to look at ClO, we're actually going to have a lone electron, which is something we almost never draw. Now, remember, for formal charge, we want to try to get formal charges equal to 0. If we get the formal charge to be 0 on each of the atoms, we know that would have to be the predominant structure. If we can't do that, the more electronegative atom would have the more negative formal charge. But what we can do here is, if we put a double bond between the Cl and the O, and we put that one single electron around the chlorine, what we wind up with for formal charge, okay, so like for instance for the chlorine, because remember, formal charge is valence electrons minus lone electrons minus number of bonds. We get 7 valence electrons minus 5 lone electrons minus 2 bonds. Formal charge is 0. And if we do formal charge for oxygen, we have 6 valence electrons for oxygen, we have 4 lone electrons, and we have 2 bonds. So it's also 0. So this structure would be the predominant structure that you should find for ClO. But again, remember, it has this one electron here. We normally pair them up. Well, where are we going to get that electron? Oh, well, we can get that electron if we form ClO minus. That minus means we've added an extra electron. So what's going to happen here? Right? So if we draw out our Cl, and we have our 6 electrons now. Now what happens in this case is we no longer have a double bond. With that extra electron, what we wind up doing, because remember the total formal charge of an ion is going to have to equal, right, -1, because we have a charge on it now. So we have to redo the Lewis dot structure so we get a formal charge of -1. And so if we draw this one, let's look at the formal charge of the Cl. Right? For the Cl now, 7 is what we would normally have. We have 6 lone electrons minus a bond. So -6 minus 1, that's 0. If we do the formal charge of oxygen, 6 valence electrons, we have 6 lone electrons in a bond. That equals -1. So what have we done? We have the charge of our ion equal to the overall formal charge, because 0 plus -1 is -1. And so we also have the negative formal charge on the more electronegative atom, because remember the electronegativity of O is greater than Cl. So the formal charge of the O is 1, the formal charge of the Cl is 0, the negative charge is on the proper atom, and when we add up the formal charge, 0 plus -1, we get the charge of the ion.